Okay, so in this video we're going to talk about the following equation. The equation that we're going to deal with right now is force equals change in momentum over change in time. And we're going to base this off of the high-speed ball bounce video. Okay, so a guy takes a koosh ball, and I think it's I don't know exactly how you spell koosh. You take the koosh ball, you drop it down, it bounces up, and he had it on high-speed camera, and so I was able to sort of see roughly that the bounce started milliseconds, not meters per second, that's milliseconds. And then bounce ends at, I'm sorry, that's end. This is start. Okay, so just kind of like estimating from the video, I'll just go with the best estimate that we have. I basically look and I see that the bounce starts when the little time ticker on the bottom says 1913.6 milliseconds. It ends when it's 1957.4 milliseconds, as best as I could judge. So roughly it's 43.8 milliseconds, or 0.0438 seconds. So that's going to go in for that time. Now we have to make some real judgment calls here. So what I'm going to do is I'm going to say that I'm going to just sort of assume that, roughly speaking, he dropped the ball from 0.3 meters, and that the initial velocity of the ball was 0 meters per second, and the acceleration was negative 9.81 meters per second squared. And so I'm going to figure out that the final velocity was, I'm going to do Vf squared is equal to Vi squared plus 2Ax. So I'm going to get basically the square root of 2 times 0.3 2 times 9.81 times 0.3. I'm going to get 2.4. Vf is 2.4 meters per second. And then so that's going down. And so I'm going to say, right as it starts to collide, I'm going to, well, I need a mass. Before I can get anywhere, I need a mass. I have no idea how much that koosh ball weighs. I know that tennis balls weigh about 50 grams. I bet you the koosh ball is not too far off of that. And so I'm going to say that the mass of the ball is 0.05 kilograms. Just totally pulling a number out of my head. So I'm going to say that the momentum going down is 0.05 kilograms times 2.4 meters per second. And so that's going to be 0.12 kilogram meters per second. Okay, so now that's P1. Well, what's P2 going to be? Well, P2 is going to be when it bounces back up. So P2 is when it bounces back up, and how am I going to guess that? Well, I'm just going to assume, just make an assumption again. I'm going to say P2 is going to be 70% of P1, and so I'm going to say that P2 is going to be 0.08. But here's the key thing. These two momenta are in different directions. So this one has a momentum going down, this one has a momentum going up, so I have to express that as one of them has to be negative. So I'm going to say that my change in momentum is going to be 0.12 kilogram meters per second minus a minus 0.08 kilogram meters per second. So that's going to be 0.2 kilogram meters per second. And so I'm going to see that my force is going to be change in momentum over change in time. So it's going to be 0.2 kilogram meters per second divided by 0.0438 seconds. And so my force is going to be, I'm going to say 4.5 newtons. So the average force that that ball had when it struck was 4.5 newtons. Now that's the average force over the entire collision. Probably what would actually happen is the force goes roughly from 0 up to 9, probably a maximum force of say 9 or 10 newtons, and then goes back down to 0. So the average force is about 4.5 newtons, maximum force is probably in the neighborhood of 9 to 15 newtons, say. Okay, that's that video. Could be better diagrams, but you'll just have to watch the video of the koosh ball bouncing and you'll see what I'm talking about.